All right, guys, so what we're doing today is finishing up the note sheets that we started yesterday. So yesterday we went over multiplication and division, but we did not get to our complex fractions, these complex rational expressions. So that's what we're going to look at here today. And I have a feeling it's not going to take the entire hour, so it'll probably take about half the class, half, 3/4, so it's not going to be too long. Here. Now, whenever we look at these complex fractions, these complex rational expressions, we want to multiply the numerator and denominator of it by a certain term so that all the fractions in the numerator and denominator simplify out. And when we do this, we're looking at those fractions in the numerator and denominator, so the 1 over x squared and the 1 over x, so that we multiply them by something that will make the denominator simplify out. You're welcome. Now, on top we have 1 over x squared as one of the fractions, and on bottom we have 1 over x. And if we look at both of these here, well, what do I need to multiply 1 over x by to get the x to cancel out? Well, we need to multiply it by x. Because 1 over x times x would give us x over x, which would simplify out. And if we multiply it on bottom, we also have to multiply it on top. Now, the other one that we have is the 1 over x squared. Well, we would need to multiply it by and x squared, yes? So we're already multiplying it by 1x on top and bottom. So instead of adding, doing also times x squared, because that would give us how many x's? 3. Because on top x times x squared would be x to the third, yes? But the biggest denominator I have is what? Is x squared. So how many do I actually need? 2. So instead of also using an x squared, we could actually just say x squared over x squared. Now, if we'd have done the x times x squared, it would work and it would simplify those fractions. It would just mean that the numerator and denominator have an extra x that we would have to pull out later. Any questions on this here before we start multiplying? Now, we multiply through with this here, the x squared, come back here, is going to multiply with the numerators for each one of these here. So the x squared times 1 is just going to be x squared minus. Now, since we're multiplying the x squared by 1 over x squared, it multiplies with the 1 in the numerator, giving us x squared over x squared. Bless you. Now with the x squared in the denominator, it's going to do a similar thing. We're going to multiply with the 1, which is going to give us x squared. Then we're going to multiply it with the 1 over x. If it would stop acting like the cursor. We're going to have minus x squared over x. Any questions on this so far? Now we can simplify some things. Now the x squareds that are by themselves aren't going to do anything because they don't have a denominator. But, let's get a highlighter. In the numerator where we have x squared over x squared, anything divided by itself is 1. Or x squared divided by x squared would give us 1. Now in the denominator, let's get a different highlighter. Oh, there we go. Here, we have x squared divided by x. So it's not going to cancel out completely because we don't have the same thing on top and bottom, but one of the x's in the denominator will cancel out with one of the ones on top. And we can see that by doing the exponent, subtracting them, 2 minus 1 would give us 1, and since it's bigger on top, it'll stay on top. But really what we're saying is that x times x divided by x, well, one of the sets of x's will cancel out, leaving us with 1 in the numerator. And it will simplify that fraction out completely. Any questions on how we got to this point here? Now, it may be very tempting to want to simplify the x squared and x squared, but we can't since that x squared and 1 are connected. They're stuck together. The same thing is true with the x squared minus x in the denominator. So for us to be able to simplify or factor down or simplify down, we need it rewritten as multiplication. If we can factor it, it's going to let us be able to simplify. Now in the numerator, we have x squared minus 1. Well, x squared minus 1 is a difference of perfect squares. So we can factor it to x plus 1 times x minus 1. Now the denominator isn't a difference of perfect squares. Mainly because x squared, the first term is a perfect square, we can say it's x times x. But what times itself gives us x? Well, there's not anything. Now we could say the square root of x times the square root of x, because the square roots would cancel out, but we don't like dealing with radicals. But the x squared and x do have a greatest common factor of x that we can factor out. Now if we factor the x out of x squared and x, if I take one x away from x squared, we just have a single x. And if I take an x away from x, we're left with 1. It factors out completely. Now at this point here, we're used to what? Crossing the x minus 1 and x minus 1 out, yes? Now, I know we've done this and I've kind of showed this at least once before. I want to show it again just to kind of drive this point home of why this works. Because we're very used to the ability to just saying that these two cancel, so we have x plus 1 over x, yes? Why this works is going back to our multiplication that we did yesterday. Because when we multiply two fractions together, we multiply the numerators with numerators and the denominators with the denominators. And really just stick them together like we have here, x plus 1, x minus 1. So if I wanted to, I could split these back apart and say x plus 1 times x minus 1 is the same as x plus 1 times x minus 1 together, yes? So we're good with saying this? Well, I can do the same thing with the denominator. We can have x here and x minus 1 over here. And I split these apart intentionally like this because the one on the right is what? X minus 1 over x minus 1, yes? Well, anything divided by itself is what? Well, this whole thing reduces to, well, fix that. This would be x, but anything divided by itself is just 1, yes? Well, 1 times x plus 1 divided by x is just going to be x plus 1 divided by x. This is why the simplification, when we get everything factored, works the way it does. Because what we're not saying and showing in this step here where we just cross them out is this right here. That really we're breaking off those ones that are the same and multiplying them by them being divided by themselves, which simplifies to 1. And with multiplication, a multiplication of 1 really goes away. And that's what the division, where we cross them out, that's what it's doing. Because we can break it up with multiplication. Addition, subtraction doesn't work that way. So when we have it here, we can't just cancel these out because of the addition, subtraction, sticking them together. Multiplication, we can break it back apart. And I wanted to show you all this because I know it's the most riveting thing you've done all day. But to underline, this is why this works. All right. And this here is the final answer because we couldn't really simplify it further than this. We can break it apart with addition, but it actually doesn't make it simpler. It makes it a little bit more complicated. Any questions on this here? Let's look at this next one here. Now, again, when we do this multiplication on top and bottom, we're wanting to simplify any fractions that are inside of this fraction. And how many fractions do we actually have inside of this whole fraction? One. That's the 25 over a. So I want to multiply it by something so that the a in the denominator of 25 over a will cancel out. Well, we can multiply it by whatever the denominator is, which is just a. Because if we multiply it by that a, the denominator will simplify. So we do this multiplication. A times 25 over a is just going to be 25a over a. Any questions on this so far? Minus, well, we're going to multiply the a by a, which gives us a squared. Now we also have to do it with the denominator, multiply each term by a. Well, the a times 5 is 5a, plus a times a is a squared. Well, now let's see what simplifies in the numerator. Well, the only thing that simplifies in the numerator is this a and this a in the fraction, because that's the only thing that reduces or simplifies at all. Just telling us that we have 25 minus a squared. In the denominator, we have 5a plus a squared. Well, we do need to factor to see if there is anything in common on top and bottom. That way, if there is something, we can reduce it. Well, in the denominator, 5a and a squared, we have a greatest common factor of what? A, yes? If we factor that out, 5a, if we factor an a out, would be 5. And if I factor an a squared, a out of a squared, we're left with a. All right. And then just what we did there, just backwards. Because we multiplied the a by 5 plus a and got 5a squared and then factored it right back out. Now, here, we could have really left it. Because is there anything needing to be reduced in the 5 plus a? Well, no. Is there anything else in the denominator that's going to be added or subtracted? Well, no. So we could have really left it as 5 plus a times a here, what we ended up getting. But multiplying it through and then saying we need to factor it back out really didn't hurt us. We ended up just undoing what we did. So sometimes, like this here, we didn't have to multiply through. We could have just left it as a times 5 plus a. Now the numerator, we did have to multiply through, bless you, because of this here, this 25a over a. We needed that fraction to simplify, so we needed to multiply it through. So sometimes we won't have to. And if we do notice that say, hey, we really don't need to distribute this, we can leave it alone, we can. But if we don't notice that and go on and distribute and then have to pull it back out, we didn't lose anything. We didn't actually make an error. It's just added a step. Now the numerator is factorable, and apparently it wants to write in a highlighter. Well, 25 minus a squared, is that still a difference of perfect squares? Is 25 a perfect square? Well, it's 5 times 5. A squared is still a perfect square. It's a times a. We're used to it in the form of a squared minus 25, but this still works. Since 25 came first, we would put its factors first, which would be 5 and 5. The factors of a squared would be a, and we would use plus and minus. And again, that's kind of why the difference of perfect squares is nice, because no matter how the setup, as long as the two terms are perfect squares and there's a subtraction in the middle, it'll always work. Now doing that, does it give us any common factors on top and bottom? Well, yes. We have the a plus 5 and a plus 5, or 5 plus a, and 5 plus a. Which will simplify to what? 5 minus a over a. And we get this here. Any questions over any of this here so far? So hopefully this is starting to make a little more sense with what we're doing and how this is working. A little bit, hopefully. Let's do 2 more of these. So between the next 2 here, which one do y'all want to do? Y'all want to do this one here or this one here? Which one looks more difficult? Probably this one. Now, in any of these here, because picking what we need to multiply everything by may sometimes be challenging, but it's really looking at the denominators and seeing what we have. What does each one have? Now, if we look at the first 2, they both have an x plus 1. So if I want to simplify those fractions out, I'll need to multiply the top and bottom with at least one x plus 1. Now, if one of the denominators in one of the fractions in the numerator and denominator on top and bottom had more than one x plus 1, we would need more than one of it. But since in both of these cases, it only appears once here and here, we only need it once. Now we do need one other term, and that would be our x. Because of the 1 over x and 1 over x, since they both have an x in the denominator, we need an x for them, so that they will simplify out. Different color. Any questions on how we found the x times x minus, or x times x plus 1 over x times x plus 1? Or do we feel comfortable being able to find that? Now what we need to do is multiply this by each term. And when we multiply this here, the denominators for each one of these factors is not going to change. We're not multiplying by the bottom of the factors in the numerator, in the top of the fraction, or in the bottom. We're always multiplying them this by the numerators. So here the x times x plus 1 is being multiplied with the x. And x times x would give us x squared times x plus 1 for our first one. Now in the second numerator, it's being multiplied by 1, so we'll just get x times x plus 1. We'll do the exact same thing in the denominator. Apparently I'm going to write in a highlighter. And again, we'll have x times x plus 1 times x, which would give us our x squared times x plus 1. And x times x plus 1 times our 1 is just going to be x times x plus 1. Now, there are a few things that simplify out. And we only are really looking at each one of the 4 fractions. We can't look at it as a whole, at least not yet. Here, the x plus 1 and x plus 1 would cancel. And the same for the one in the denominator. The x plus 1 over x plus 1 would cancel. They would simplify to 1. In the other set of fractions, the x over x would simplify. And here, the x over x would simplify out. Thus, leaving us with x squared minus x plus 1 over x squared plus x plus 1. Any questions on this so far? Now we do need to simplify and combine like terms. Now the denominator, since we're adding the x and 1, the signs don't change. So the denominator is going to stay x squared plus x plus 1. Now the numerator, since we are subtracting the x and 1 from it, we get not positive x, but negative x. And the positive 1 is going to become negative 1, since we're subtracting the whole thing from it. And that right there is actually the final answer. Because x squared minus x minus 1 won't actually factor. Really, for this to be able to factor, we either need the numerator to have 2x squared or minus 2 for us to get a middle term of negative 1. And for the denominator, the x squared plus x plus 1 to factor, we need the middle term to be actually 2x or negative 2x for it to work. So this here doesn't factor any further than what we have. Another way that we could check it is using the b squared minus 4ac method that we've gone over before. If we plug in those values into the square root and get a whole number, it lets us know that it will factor. If we get a decimal or negative number, then it won't. Any questions on this here? All right. Any questions over anything we've done so far? Or do we feel good with this here? Okay. Do we want to see one more of these? Well, it's like no, but the ones that are still awake. Any questions over these here? No? If y'all feel comfortable with these here, the homework is a worksheet. And I'll go on and pass that out. If for some reason that y'all do lose one of these worksheets, they are in Google Classroom. I do post them up there. So if you're not sure of how something's written, especially with, as y'all have seen how the ink fades when it's printed, you can check there. It will give you a clearer picture of the worksheet.